Karibu SolidWorks Tanzania. This is a continuation of our industrial automation series, and today we have this very interesting project. So today tunaenda kufanya a material handling project ambayo inafanya pick and place mechanism. All right. So so right here we are going to pick some plates. So I'll pick plates of this kind, right? A plate of this kind, and then I'll be placing them on a stackable box like this one. Okay. Yeah. So um here what happens is so we have here our pick and place robot right here, back here. And if you click on it and you right click on it, you go to configurations, you will see that this robot or this pick and place setup, it can either be digital or it can be analog, or it can either be both digital and analog. All right, but you see I've set it to analog control, so we'll be controlling our picking and placing mechanisms analogy. All right. Okay, so how do we do it? So about this whole setup, so nearly drag drop this conveyor, right? So again, I can do this for you. See how I did this? So light loads here, I drag dropped a 4-meter conveyor like this. Okay, and then I rotated it like that, right? And then I also drag dropped a 6-meter conveyor like this. Okay, and I rotated it and I moved it here like that. Okay, so I made sure they are almost at the same alignment like that. And then I drag dropped my emitter. So the first emitter, rotate it, move it, and place it here like that. I hope you have seen that. Okay, so we can say right click and duplicate, get another one, and I placed it on the other edge like that. Halafu nika drag drop my remover. All right, move it this way. Okay, like this. So my remover is on this other side. Move it down. Okay, okay, like that. And then I went to stations and I dragged this 2-axis pick and place robot. So our robot or our pick and place mechanism has two movements only. It can either move along X or along Z, right? So I drag dropped it like this here. Okay, and I rotated it with Y, press Y. Okay, so there it happened like that. Okay, and then I have, so I mean I can just explain about the rest. I mean you umeshaelewa what I did here. So I also drag dropped 2 sensors, one on the plate conveyor side where the plate is the item I told you I'll be releasing. So let me delete first this because I was just showing you how I created my pick and place material handling station with 2 conveyors. Okay, right. Okay, so right here you see I've placed 2 sensors. So I think you remember how I named it. Hii ilikuwa tu ni capacitive sensor, nikai click, nikai highlight like this. Okay, alafu nikai rename into a plate sensor. Hii ilikuwa tu inaitwa conveyor 0, belt conveyor 0, nika place hiyo actuator tag, nikai highlight, nikai rename like this, nikai rename to with my keyboard, nikai rename nikaita plate conveyor. All right, and then I also placed this one and I called it a box conveyor. This is where our stackable box will be coming. So on the emitter, ni right click, nika set time. So it has a difference of 1 second. Every 1 second a box is released. And then on the part to emit, I'm only emitting a stackable box. Only a stackable box. And on this end, right click on it, also 1 second difference. Every 1 second a box is released. Okay, and then on the part to emit, I'm only emitting a blue raw material, so only a blue raw material. All right, yeah, and then yeah, so that's it. And what else did they do? So what mechanisms am I looking for here? Ukiangalia hii pick and place mechanism yangu unaona ina a lot of sensors and actuators. All right, we have sensors and actuators. All right, so this if you come here ukiweka kasa yako hapa utaona nakwambia this is a sensor, a 2-axis pick and place 0 rotating, sensor for rotating. This is a actuator for rotating, so clockwise. So ukiangalia hapa we have an end effector here. This is our end effector here, right? But then nimesema hii device yangu yenyewe it does not rotate, right? Hata ukija hapa inasema ni 2-axis pick and place. It only have 2 axes. It can either move along X, so it can move this way along X, or along Z, downward, upward, or left, right. That's the major movements of my pick and place. But then you see here, you see here in other layout, you can have this manipulator rotating either counterclockwise or clockwise, right? And you'll have a sensor here for the rotation, like, okay, has it rotated how much, right? How much should it be rotating and stuff like that. And then I have my if you come here, I have a gripper. So a gripper is an end effector. This is an end effector of my pick and place. You see this gripper here can either rotate counterclockwise or clockwise, and it can have a sensor. Kwa mfano, hii gripper yangu nikiangalia vizuri, this is a vacuum based gripper. Unajua kwenye gripper ama kwenye end effector, unaweza kuwa na mechanical gripper ama pneumatic gripper. It grabs an object using, so this one uses vacuum to grab an object, right? Lakini inaweza kuwa magnetic gripper ambayo inashika vitu ambavyo ni metallic. Lakini pia at the end effect here tunaweza tukawa tuna sensor, let's say a sensor like a proximity one ambayo ina detect object position. So when the pick and place effector is moving down, it can detect maybe after a certain distance, then there is an object, grab it and then place it on the other side on a box, right? So but this one I will be controlling it analogy. Kwa mfano kama ningekuwa na sensor hapa, ningekuwa na use the sensor to activate hii pneumatic grabber. ningeenda kwenye digital, lakini pia ningekuwa natumia sensor ku measure my movement from from this conveyor to the other conveyor, and also a sensor to move my movement on z axis up down. Then ningekuwa na digital configuration of this manipulator. Umeona? So ningefunga labda proximity sensor here ama capacitive, kwamba hii move down ina detect where we are, ama hapa kwenye hii pneumatic grabber ama hii vacuum grabber ningekuwa na vision sensor somewhere, ningeifunga vision sensor somewhere, let's say hata hapa kwenye hii end, alafu ingekuwa inaangalia if there's an object, and as soon as the object is seen here, the gripper will be, or the pick and place will be activated to move down, grab the material and place it on the box on this other side. Okay, so if I press run here, so you see this conveyor releases a stackable box as I presetted it on the configuration kwenye emitter, and this conveyor releases a blue raw material as I configured it on this emitter. So what happens here is this box will be coming this way, and this box sensor here is responsible for stopping the box conveyor when the box is detected. So when this stackable box comes here, okay, the sensor, so let's say I click the box conveyor here and I force it to move without any program. I'm just saying how these things happen. So what I want it to do is, the box is moving, so this conveyor should be bringing this box, stop, again, stop. Okay, so you see I want this sensor, unaona hii sensor iko active. When the sensor senses the box, it should stop this conveyor from moving, and then this conveyor here will be bringing the blue raw materials. So let's say this is moving, okay, then stop. So you see this plate sensor is there to stop this conveyor when a blue raw material is being detected. So unaona if this is on stop and this one's on stop, now procedures follows. So the first procedure is the two axis pick and place should move Z. So see the sequence should move down to grab this raw material. So let's click this where is Z? So this one, two axis pick and place, Z position, this is a sensor and this is an actuator set point. So we are using a manual move, so we are hii manual mode manake ina depend on voltage 0 to 10, manake hata maximum distance it can move along x and z is 10. So click on this, you see here, so you can force it down, you see from there up to the object here is maximum 10, nimeiforce down lakini naweza reduce, you see I can force it. See, so first I have to set a sequence of this x-axis pick and place to move down by 10. Okay, by 10. Okay, 10 maximum. Then it has touched the raw material here. When it touched the raw material, I will activate grabber. So grab plate. So here nili rename, right, nilirename nikaita grab plate. So grab plate nika actuate grab plate here, grab plate actuate. So you see it's active, so that means the vacuum is on, hii raw material itakuwa imeshikwa. Now I have to move my z axis up again, up to 0. So move it up to 0, you see, with the grabber on. So you see it has grabbed the plate raw material, right? That's the third sequence. First sequence ilikuwa move down, second grab, third move up, and then fourth. So hizo nazirite tu pembeni kwamba distance zangu nitakuwa na move how much, alright? Lakini kama si hivyo basi ningekuwa na sensor ambayo let's say vision sensor imeona imeona a raw material, move down, match, and then when you move down, grab, and then come up, right? Now we are going to move on the X. So set point on the X like this, and then say, let's force. So nimeforce, lakini unaona nikimove it all the way to 10, umeona where it is. It's a little bit away from the stackable box. So let me move back a little bit, maybe at 8. Okay, so I know now my my pick and place should move by 8 along X, and then it should then move down. So let me move it down slowly. I'm moving the Z axis down to see. Yes. So kwa sababu nitakuwa na move plate kadhaa kadhaa, zitakuja plate kama, so I want to put 3 raw materials on this box before starting the conveyor to go away. Okay, so I'll be picking from here 1, 2, 3, and then move away. Another 1, 2, 3, and move away. So you see, I'll be counting the raw materials that I'm placing on this stackable box. And then after the count is finished, the conveyor should start. Move this stackable box away, bring another stackable box, bring another raw material, again place 1, 2, 3, and the procedure continues. So kwa sababu hapa nataka kuweka 3 stackable box, I should not move my my z axis all the way down, kwa sababu sasa nikija the other round nitashindwa kumove all the way down. So I have to move at least maybe up to, let's say, 6 like this. So let us assume this, all of this has a 1. So 1, 2, 3. So nataka niache distance, okay, distance, so that nikileta hizi stackable box hapa sitazigusa. So maybe nitakuwa na move, nikishafika kwenye stackable box nita move the x axis by 6, and then nita release grab plate. So nita deactivate grab plate ama na deactivate vacuum like this. Tap. So unaona imeachia ile raw material like this. After that, I want this one to move back. All right. And also, so that's the sequence. Okay, so you see it's manual or analog set points. And then this to move also back like that. And this now, pick another plate. When the 3 plates are done, the stackable box should move away. The conveyor should start and move the stackable box away. Bring another raw material, bring another stackable box, repeat the sequence. So yeah, I hope you have captured that. So let me close these ones like this. Okay. Yeah, so there you can take a snapshot of my layout here. So let me stop this. Yeah, you can take a snapshot of how this looks like, so that you can create your own layout. Okay, so the other thing here that we're going to do, let's go to the driver file, drivers. So this is how I've connected my Siemens PLC controller with my inputs and outputs. So I have 3 digital inputs, I have 3 digital outputs, and 2 analog outputs. All right. So this looks like they are forced. So let me click. This one should not be forced. Release it so that it's now controlled by the program. And this one should also not be forced. Release it like that. Okay. So go back to drivers. If you see this alarm hapa, inamaanisha hiyo device iko forced. Emitters and removers normally huwa wanaziforce, lakini unaweza ukazicontrol na program. I've shown you in the previous presentations. So I have my 2 analog outputs where I'm controlling the axis, X set point and Z set point, kwamba how much are you moving along X, how much are you moving along Z, stuff like that. So I'll be using a signal to control the, so the grab plate will be a digital output, all right, because I'm sending a signal to command grab, activate grab plate, all right. So here you see I don't have, ukiangalia hapa sina any switchboard, sina start push button, sina reset push button. So I'll be using this icon here, the run mode icon, that when I press it, this will be my start stop button. So that's why here on drivers, nimeka factory IO running, which is right here, and drag drop factory IO running. So I want to use my factory IO running as my switch start stop. The other very important thing I want you to notice here, ukiangalia hapa, I have my inputs offsetted from I5.0 onwards, not I0.0 on the address of the inputs. Why? This is very important on factory IO kwa sababu before nilitumia address 0.0, 0.1, but then there was a lot of confusions and mismatch, and the system wasn't acting right. So for factory IO, if we are doing a complex or a medium complex control of our layout, we need to offset our inputs at least from 5 point something, right? So my input status, input address start from I 5.0. So hata kule tukienda kuandika zile PLC tags, tutaanza na address I 5.0, not I 0.0, but on the output is fine. I just started with Q 0.0. How did I offset? Go to configuration. You see here is my model S7-1200 as usual, double walled for the data type on IO configuration. But then you see here bool inputs, I've offsetted it. I just wrote here 5. So ukiandika hapa 1 itaanza 1.0, ukiandika 2 itaanza 2.0, counts to 16. But on the outputs unaona sija offset anything, it starts from 0. Our analog and analog input and outputs as usual, they start from an offset of 30. ID 30.0 and the QD, ID 30 and the QD 30. Those are the four analog input and analog outputs. So very important, take that into account. Okay, so yeah, so this is it. So now, as we've seen that, let's go to our Siemens TIA portal. Okay, so here I'll just delete all the networks here that were here before. So I have to reuse this. I want to reuse this block. So Control Z, Control Z. Okay, yeah. So I just want to reuse this template block to write our program. So let me just say compile it to clean everything here to make sure everything is fine. Okay, all right. So we start with our tags. So we begin by writing tags as usual. So you have seen I have 3 digital inputs, right? So I'm starting with my 3 digital inputs. So the first one is factory IO running. I said I'll be using my factory IO start stop button as my start stop inputs. So factory IO running as my, now here I have to change this address. This is I5.0, I5.0. Okay, and then I will have my plate sensor that senses the plate has arrived, and then I'll have my box sensor that senses the box has arrived, the stackable box, and then that's it on the inputs. And then I have my 3 digital outputs, so 3 analog 3 digital input, then 3 digital outputs. So first I have my plate conveyor, a conveyor that brings the plates. So I'll change the address here. This is Q 0.0. And then I have my box conveyor, So a box conveyor, this is Q0.1. This brings the stackable boxes. And then I have my grab plate actuator, grab plate actuator, which is my vacuum grabber on Q0.2. And then on the analog output, I have an x-axis moving, an x-axis set point. I'll just call it x-axis, x-axis, and this is an analog. The data type is real. Yeah, the data type is real, and this is my QD30, QD30. That's why I connected it. And then here I have my no z-axis. My z-axis is QD34, right? Okay, so after that, that looks good. That looks good. Now let's go back to our main like this, and let's start writing our programs, our program line by line, sequentially, according to the step that happens. Okay. So first, tunaanza na reset the system, set and resetting the system, set and reset the system, set and reset system. So how do we set the system on, and how do we reset it to off? Yeah, system, yes. So here I'll have my open switch like that, and then I'll have my comparator. Okay, I'll have my comparator. Comparator, where's the comparator? So here, comparator, like that. And here I'll have set, another one, set. Okay, so here I'm setting my box conveyor and my plate conveyor. Okay, so let me have here my factory IO running, because nilisema hii hapa ndio my start stop button, start system, stop system. So here I'll have my memory tag. Okay, so this memory tag, we will see what it does as we go forward. So it just stores some memories, right? And say this is 0. So this memory tag here, initially we we um we are writing on the side of counter kwamba tumesema pale tuna place blue boxes kwenye stackable box. So ile sensor ya pale ile sensor ya plate sensor ikisha sense the first raw material, ita increment count, itakuwa 1, alafu ita stop conveyor. So ikistop conveyor, ile take the first blue raw material, ita stop the conveyors, na upande wa stackable box pia ikidetect stackable box ita stop pia the conveyor. So hii tumesema pick and place, ita pick 3 boxes, right? Ita pick, ita place, alright? And then ikisha place, itakuja another box, ita pick tena, ita place, itakuja tena another box, ita pick, ita place, right? So hapa tumesema when it's 00, like when you don't have any memory of the counter on the system, start the conveyors. Alright, all conveyors should be on. Tukianza counter, tukiwa increment counts, then tutaanza another tuta rewrite another sequence on what should happen, kwa sababu hii conveyor ya ya plate ama raw material itaendelea kubring raw material kuziweka kwenye stackable box, na zikishafika 3 ndo itaruhusu ile stackable box move away, we bring another stackable box and then we keep picking and placing. So data type here is double walled, and here is 0, as I've written 0. So we have if we, with this memory bit hold, we will have here plate conveyor. Plate conveyor will be set on, and box conveyor will also set on. All right, now we proceed down here and we say extend this. So we have anomaly close. So now anomaly close. So we are resetting our we are looking on how to reset our plate conveyors, and also to return our pick and place manipulator into its origin. All right, into its origin. So here we have move, a move block. So move. All right, so I'm moving 0. So we will see where all of this goes, all of these memories goes. So here I'll have my factorio running like that, and then I'll be moving a 0 to MW10, a memory hold MW10, and then I'll extend it from here. I'll have another move box here. So resetting the system, I'm resetting everything. Now I'm moving a value 0 into QD30, ambao QD30 ni x-axis, manake the x-axis should go back to its origin. So x-axis can move from 0 to 10. So I'm moving a 0, so it's going to its origin. So 0.0 here. Na kwa nini nimeandika 0.0? Kwa sababu ukumbuke x-axis na z-axis ambazo ni QD30 na QD34 data type ni real data type. So on real data type we use decimals most of the time. So 0.0 to QD30. All right, and another value here, I also move. I'm moving another 0.0 to QD34, which is my z-axis. All right, okay, to QD34, and then I'm also moving another value here, another value like this. So move, okay, I'm moving another 0 to a memory bit holder MW20. We will see where these memories are located and what they are storing as we go forward. And then I'll reset my plate conveyor, right? Plate conveyor, right? And also, okay, so this is reset, not set, reset, okay. And then I'll also reset, so here, I'll also reset my box conveyor, like that. Okay, looking here, everything looks good. So here, this is my setting to set the conveyors, and this one here is for resetting. So you see when the factory IO is pressed the high, right, this will be deactivated, right? So I'll set my conveyors when it's released, right? So when it's released, we'll press the stop push button, inasema inakuwaga na normally close switch NC. All right, so it move 0 to reset all the conveyors, reset all the pick and place. Now after that, We are also resetting our grab plate also. Reset it. All right. So here reset grab plate, plate grabber, which is vacuum based actuator. Okay. So after that, let's go to another network. How do we stop the conveyors? Stopping the conveyor. Hapa tunaongelea stopping the conveyor when stop conveyors, not resetting, stopping. So unakumbuka nilisema kwamba tukidetect stackable box conveyor lazima istop, alafu tukidetect plate pia ambayo ndo raw material, the conveyor should also stop. So uliona pale nilikuwa na plate sensor kwa ajili ya kustop plate conveyor, alafu I have a box sensor kwa ajili ya kustop box conveyor. Lakini the other thing I should say here, the sensors, I need to have the sensors on the positive trigger. Like kama unakumbuka before tuliongelea P trig na N trig. So positive trigger is when the box is entering the sensor. So it should activate on the positive going pulse. Ndo ile boxi ndo conveyor isimame mapema wakati box bado ipo kwenye entry. Okay? So I will have a positive trigger bit kwenye sensor ambayo positive trigger itakuwa ina reset the conveyors so as to pose the stackable box and the blue raw materials exactly almost close to the sensors. Usipoweka hii P trig na N trig, then ile sensor yako itakuwa na keep sending signals kwa sababu ile box bado si pana, so ikiwa inapita pale bado itakuwa inatuma tu on off on off on off. Lakini tukiwa na P trig, manake only when the sensor has seen it entering, then it just send that one signal of positive going pulse, and that's what is stored and that's what takes the action, right? Okay, tungekuwa tunaangalia labda exit sensor. Ingekuwa exit sensor, manake exit sensor tungeweka n trig ama n bit pulse, manake when the box has exited the sensor, now the pulse start going down, which is a negative trigger, then we can say maybe count. Tukienda kwenye sensor ambazo zinafanya counters, itakuwa ni vizuri kama tuna count exited boxes, then itakuwa vizuri ikiwa n trig, ndo iwe box imesha exact, ndo ina count. So get yourself aware of P trig and N trig. All right. So here I'll have this one here, and then output here, and another one here, this way, and then output there. So this one I'll change it to P trig, and this one also to P trig. This one to reset to stop the conveyors because they were setted, and also to reset here to stop the conveyors because they were setted. So here I'll have my plate sensor, and here I'll just store this memory on M0.1. So I'm just storing the memory of the trigger here, like trigger and store, all right, trigger and store, another trigger, store it again. So M0.0 ni temporary registers ama temporary memory holders, all right, they can be rewritten. And then here I'll have my plate conveyor, and then here I'll have my box sensor, and I'll store it on M0.2, and then here I'll have my box conveyor, like that. Okay, everything looks good on network 3. So we go to network 4. So on network 4 we are starting the auto cycle, all right, the automatic cycle, all right, kwamba move the conveyors, stop when the sensors have sensed the box and the plate, and then place 3 raw materials on the box, and then the box goes away again, bring another stackable box, bring other raw materials, and the cycle proceeds. So we are starting the cycle from 0, and then we increment from there. So tutakuwa tuna increment kulingana na ile sequence, kwamba tunajua sensor ikisha stopisha raw material na stackable box, the first thing happen ni kwamba our manipulator ama our pick and place should move down. So move Z, then grab, then move up, then move X, then move Z, release, then move up, then move back X. Repeat again. All right. So here we're writing a network for starting an auto cycle. Start auto cycle. Start auto cycle. Okay, so starting the auto cycle. So here we have our two sensors, this one, that one, and then we have our comparator block like this, and then we have here our increment block. So kwenye math function, no, hapa kwenye hii block tutatumia an incrementation block. Incrementation block inafanyaje? Ina increment procedures, kwamba ukiwa from 0, sensor ikisense maybe once, ina increment value inaenda 1. Sensor ikiona tena ingine, ina increment value inaenda 2. Inakuwa more or less like a counter, lakini it's not a counter. Yenyewe ina increment sequence, kwamba this is sequence number 0, sequence number 1, sequence number 2, sequence number 3, etc. So here I'll have my sensors. So if we have our plate sensor, and our box is sensor high, right? And then we have a memory hold bit here, our MW10, right? Which is up here to MW10 somewhere. We had an MW10 here, this one here. Initially it was a 0. Now we are incrementing this memory. Okay, this was it can be word, it can be double word, it's fine. So word. So this is 0, the beginning. So here we have our increment block, and we are incrementing this MW10. We're incrementing it, right? So when the plate sensor is high and box sensor is high, and this equal to 0, increment it. So now with this one, MW10 will be incremented into 1 from this block here, kwa sababu itastopisha plate, itastopisha block, this itakuwa memory store, itakuwa incremented into 1. Ikishakuwa incremented, now tunajua tuna move x axis down, I mean z axis, move z axis down. So move z axis down, right? So moving z axis down, we will have our comparator block again. So comparator block is used here very often. So now kwa sababu tumesha increment hapa juu, tumestart auto cycle, sensor zetu ziko high, on memory set tulikuwa na 0 at the beginning, at the origin, and then increment. So if this and this are high and high, so we increment this memory to 1, so incremented it. So now here and on the move to z axis, manake now this has incremented into 1. So when our MW10, our memory 10 has incremented, so this one here is double walled, yes, and this is has incremented into 1. Okay, then we move z axis down. Kwa ukumbuke ilikuwa z axis ilikuwa na move 10, ndo inakutana na ile blue raw material. So we come here, we say move. Okay, tunapeleka value, ujue ilikuwa real value, so 10.0, we move 10.0 to QD34. Our z axis ilikuwa ni QD34. Okay, alafu sasa tutaweka a timer delay hapa. Hii timer delay inatusaidia before moving to another action, we wait for some time, kwamba move down, wait a little bit, grab, wait a little bit, move up. So don't use hizi timer on delays. So we will have timer on delay. Where is our timer? Here. So we have timer on delay here. Okay, all right. This is our timer on delay, ODB 7. All right, ODB 7. This is our first time on delay, DB4 or DB7. So here we are delaying 1 second. So 1,000, wait for 1 second before moving to another action. So 1 second, right? And then after 1 second, we will use that as a positive trigger of when 1 second is done. All right, a positive trigger here of when 1 second is done. So here we have our timer or DB7, this very last one, right? The output of it, the Q, okay, the output. So this one I have taken in the output of the Q of my timer here. When the 1 second is done, the Q, then Q comes here, and then this one here is also a positive trigger. All right, let me store this on M1.1. Okay, and then I have to increment my what? I have to increment my MW10 kwa sababu procedure 1 sasa, procedure 1 ina move down, wait 1 second, increment MW10 kwamba I have completed the first sequence. I'm going to the next sequence, which is sequence 2. So I'm incrementing my MW10 here, okay, like that. Now I'm going to another network. Okay, go to another network. Now hapa increment now MW10 memory ilikuwa 1 ndo tumemove z down. Now tukiincrement hapa after this delay tunajua ni nini? MW10 itakuwa 2. Sasa sequence inayofuata itakuwa nini? Grab plate, grab the object, si ndio? Grab the object, hiyo ndo sequence inayofuata, ambayo sequence inaendeshwa na memory ipi? Hii hapa, output memory hii hapa, ambayo MW10 itakuwa equals to 2. So again hapa tunaweka hii, oh no, z, tunaweka comparator. Our comparator now is when MW10 ambao ni double word, sorry, MW10 ambao ni double word, yes, equals to 2, right? Incremented. Now when our memory is incremented into 2, we have first to set the grabber. Okay, activate the grabber so as to grab the raw material. Now the grabber is on, and then again kama kawaida we need a timer on delay hapa kabla ya ku increment into another memory, ambayo another memory itatusaidia kupata another action sequence. So this one kwa sababu tuna grab tu dakika sifuri, tutai delay just for 500 milliseconds, nusu sekunde, and then after that tutakuwa tuna p-trig ambayo itaenda ku increment our MW 10 again. So here we'll have our p-trig, alafu here pa IEC hii hapa, this timer output, make sure it's like this, DB8, so DB8 output. So let me store it on M1.0. all right, and then now we are incrementing MW10. So we're incrementing it, so the MW10 now will be 3. So we go to the other sequence, right? So the other sequence here is we move the Z up. Z ili move chini, grab, though now Z should move up on our pick and place robot or pick and place system. So move Z up. This is our sequence, and on moving Z up by MW10 equal to what? Equal to 3. So comparator right here we have our comparator, and then here this is a double walled, no, double walled, yes. So here we have our MW10. When our MW10 is equal to 3, right, we move 0.0 to z kwa sababu 10 ni maximum z, 0 ni origin z. So moving up manake we move 0.0 to z. So here say move. Okay, so we move a 0.0 to z, which is our QD34, QD34, like that. Okay, right. And then again timer on delay as usual. So tunakuja hapa tunatoa timer on delay hapa, TON hapa. This timer on delay? No, not this one. Timer on delay. Let me delete it. Okay. Timer on delay, like that. Okay, okay. DB9. And then here I'm delaying this for 1 second, so 1000 milliseconds. And then its output also p-trig here, and I have my to increment my memory MW10. So here I have IEC timer, the final timer, this one, the output of it. This is M1.2 memory tag. And then here I'll just increment my MW10, like that. Okay, the other network now, kwa sababu nisha move Z up, so now I have to move on the x-axis. So move x-axis forward, move x-axis forward. So here again I'll have my comparator block like this, and in here we know we have a double walled, yeah. So this is my MW10. So when my MW10 is equal to 4 now, so I'll have to move. So hapa nitamove x-axis by 8. Kama unakumbuka wakati napimisha niliona pale 8.0 itakuwa ndo imefika position nzuri kwenye stackable box. So this is I'm moving to my QD30, which is my x-axis position 8. And then again I'll have a timer on delay here. Okay, so this one here delay for 1 second, all right. And then after that I have to increment my MW10 as usual. So here I have to need to have a positive trigger here where I'm taking the output of my delay timer 10, the output, and then I'm storing this on M1.3. okay, and then right here I will increment my MW10, increment. So here increment my MW10, like that. Okay, I'm moving to another sequence now. Nimesha move along x8. Now I have to move it down. So move z axis down. So it's just a sequence. That's how we write the PLC programming. Move z axis down, na tukimove down pia tuna release and release the object. Manake ku release object manake tuna deactivate nini, tuna reset ile grabber, ile vacuum grabber, and release object. So here I'll have my comparator again like this. I'll have it on double walled. So here I have my MW10. This is now it is 5, incremented to 5. I have to move. So I have to move a 6.0. Nilisema ikiwa pale kwenye stackable box haita move exactly down, ta move at least kwenye 6 ndio iweze kurelease zile 3 stackable, kuweza kurelease zile 3 blue raw materials, otherwise itakuwa ina interact nazo. So QD34, oh sorry, QD34 Z, and then again I'll have my timer on delay here like that, and my timer on delay. So I'll delay this for 1 second, 1000 millisecond. Okay, and the output of the timer, as usual, I'll use it to increment my I'll use it to increment my memory. Okay, right here. So this is positive P-trig, and then here I'll have my increment. So I'm incrementing MW10. Okay, here I have my IEC, ilikuwa ni timer 11 output. Okay, what timer 11? Yeah, this is M1.4. all right, and then I also have to reset my grabber. So na reset ile grabber, ile vacuum grabber, ndo niweze kurelease nini, kurelease the object. So grab plate, yes, like that. Now after that I have to move z axis up kwa sababu nimesha release hiyo plate. So hapa move z axis up. Alright, so moving z axis up, hapa nitakuwa na comparator block like this. Okay, hapa ni double walled. So here is MW10, and down here this is incremented to 6. Now here I'll have my move block. I'm moving a 0.0 to the z axis, ndio ile iweze move up to the original. So I'm moving it to QD34. Okay, and then I'm having also a timer on delay as usual, delay for some time before taking another action or a sequence. So delay here for another 1 second like that, and then I use the output of it to increment my MW10. So here, right, I have P-trig positive here, and here I have to increment. So here I have IEC, so the latest timer, this one, the output of it, this is M1.5, stored on M1.5, and then I have to increment my MW10. Okay, now after incrementing this, now the network 11, this will move x-axis back to initial position, so I have to shall move z up. So move x-axis back to initial position. Okay, so here again I'll have my comparator block, and my comparator, this is a double walled, no sorry, this is a double walled, and my comparator block, now my MW10 is equal to 7, incremented to 7. That's the 7th sequence. Now here I'll have my move block, I'll move 0.0 to the X position, so QD30, right? And then I will increment again now I'll just increment, no time delay, so that to begin the other procedure mara that. Okay, so I have to increment this mw10 mw10. All right. So after that, on my other network here, I have to start auto cycle again. So starting the auto cycle again, kurudia tena whatever happened up there, auto cycle again, cycle again. So here I'll have my comparator block again. So this one here, this is a double world, and here I'll have my mw10 equal to 8. Now it's 8. Here I'll have a tag m2.0, a memory tag, and then here I'll have a timer on delay. Okay, a timer on delay for just for 1 second to go to the other procedures. Okay, a timer on delay just for 1 second. Okay, so this goes to here like this, goes to a move block. So this one here is my my latest timer on delay, the output of it. Then we have to move. Now we have to reset our mw10. Move a 0 to our mw10. So tuna move a 0 out, ndo tunaenda kule juu kwenye start auto cycle. Kwa mw10 ikiwa sifuri, tuna start again counting the sequences from the very beginning. And hapa we have to set our plate conveyor on again. Hapa sasa ni kwa sababu plate conveyor inaendelea count mpaka tufike zile ngapi? Manake hapo bado box conveyor itakuwa imestop, plate conveyor itakuwa inaleta another object and then another object. Zishafika 3 ndo ina move tena stackable box, right? So counter for number of plates per box, ambayo sasa ndo inafanya zile stackable box ziwe 3 by 3. Counter for number of plates per box Okay, so here we have our m2.0 right here. This when this tag is on, so unaona hii tag itakuwa inaletwa on off, zikifika tena 8 on off, zikifika tena step 8 on off. So kisha kwa 3 times we have to move the stackable box. So here I'll have my P trig for m2.0. So let's store it on m3.0. Okay, so there I'll drag a up counter. So counters, so CTU, one up counter like that. Okay, so this up counter I'll have here also a normally close, Control Z. So I'll extend here a normally closed factory IO running. This will reset the counter. Okay, and preset value here. Oh, so I'm stacking actually 4 boxes. Let me stack 4 boxes. So nimeweka kwenye 6. Kila moja nisema ina 1 1 2 3 4 1 2 3 4. All right, and then the output goes here to when the counter is done. We are going to set the box conveyor, and we are going to also have a tag here, an m4.0, that will control something else, right? So here I'll have my factory IO running, like that. Okay, And I also have my this tag here. This tag here will be resetting my counter. This tag will be resetting my counter. Either you press stop factory IO, ama this tag here will be resetting my counter. All right, comes here, and this one here is M4.0. All right, now that everything is set, this is all about my networks, right? So this is all about the program. So let me compile this. Say compile, compile the program. Compiled. Let's see if there's any error. Zero errors. Now you go to online. We say start simulation. Start simulation here. Wait for it a little bit. Okay, then say consider as trusted. So nadhani tumeandika program yetu vizuri tu kwa sequence tu incremental, ilikuwa na increment ile memory ya sequence, kwa sequence namba ngapi, mwishoni tumereset sequence tuanze again sequence ili tuweze kuweka zile three boxes kwa kustart stop ile plate conveyor differently from box conveyor. I hope you have understood it. Okay, so this one is running. Now we come to download the program. So we download our program into our controller. And then we say load. And then we say finish. Okay, so here we go online. Everything should be blue here. Green. Okay, everything is green. Everything is good. So monitor. All right. Okay, so after that, we are going to our factory IO and we say connect. We are connecting it to our PLC portal so that they communicate. Okay, marvelous. So they are communicating. Minimize this. Come back here. Tunaweza tukaficha hizi tags. Tukuja kwenye view, sema uncheck sensor tags, view uncheck actuator tags, ndo hapa pawe pako clean. After that say run. Right, let's see. Okay, see, picked, placed. Again, you see what's happening here. Another object. Hata ukienda kwenye TIA portal kumonitor utaona the program behaving exactly how we wrote it. Then ita pick the third box. Tulisema ina pick 4 boxes. Okay, then fourth box. Tukisha pick 4 boxes, tukisha place tuna reset sequence counter, stackable box ina move away. Inakuja another stackable box, pick again. Voila! You see, that's beautiful, right? Yeah. So yeah, I hope you have captured a lot from this session. Yeah. So I think you have understood what we did here. Yeah. So keep moving forward, keep practicing, keep doing programming, and I'll see you at the top. Ciao.